4.1 Part 2 Ratios Tables. I can find two ratios that describe the same relationship.
Excellent. Two ratios that describe the same relationship would be equivalent ratios, but we're going to use ratio tables to help us do that. Are you guys pretty confident with the I can statement?
Yeah.
Awesome. Okay, we're going to slide down to number 2. We made some Arnie Palmers, which is a mix of lemonade and iced tea. There is your visual. 1 cup of lemonade and 3 cups of iced tea create a very, very refreshing Arnie Palmer drink. What I asked you to do was to create a bigger batch of Arnie Palmers. And what y'all told me you did is you took 1 cup of lemonade and you doubled it, right?
Yes.
And if you double the 1 cup of lemonade, in order to make the ratio equivalent, you must also double the iced tea. So the 3 cups of iced tea now becomes 6. And what you're noticing happening is if I have 4 total cups, remember I'm used to going across, not up and down. If I have 4 total cups of lemonade and iced tea and I double my recipe, how many total cups do I have? 8. So obviously it doubles as well. So ratio tables would just be a way to organize equivalent ratios. We are calling these arrows basically the equivalent of what, everyone?
Bubbles.
Bubbles from the bubble method, right? Are we only using multiplication and division to calculate ratio tables?
Yes.
Yes. However, is it possible to use repeated addition and subtraction?
Yes.
But we're not going to. We agreed not to, right?
Right.
Because it gets more confusing if you go down that route. Number 5, we're going to skip over. Number 6, in this situation with dogs and cats, I gave you the fact that one of my friends had 4 dogs and 6 cats, and another one of my friends had 12 cats and an equivalent amount of dogs to my first friend. So you figure that out by calculating how many more times dogs my second friend had, right?
Yeah.
Which was how many more times? So you have to multiply that person's dogs by 2 to get to my second person's dogs. I'm not being very clear on how I explain this, but do you understand what we're doing here, right?
Yeah.
Okay? And then you also had a missing number here, which you use equivalent ratios to solve for. But really the big understanding would be number 6. If you get what happened in number 6, you are golden. You are wonderful. We had a box of, we had some crackers, and on the box it said if you eat 36 crackers, you're going to consume 240 milligrams of sodium, right?
Yeah.
And my question to you was, well, how many milligrams of sodium would you consume if you ate 15 crackers? And so what you guys told me is to get from 36 to 15 is not an easy task. Can you use multiplication or division to easily get from 36 to 15? No, it's not easy. So who was this? Who did this example right here? Tate came up and he labeled, or he created a ratio table, and he started with crackers and then sodium, and he started with what he knew. 36 crackers is 240 milligrams of sodium. And he knew he needed to get to 15 crackers, but again, going from 36 to 15 is not real possible unless you do multiple steps. So Tate decided to take his 36 crackers and he divided by 6. And if he divided the crackers total by 6, he must also divide the sodium total by 6, right?
Yeah.
So his new ratio table said 6 crackers represents 40 milligrams of sodium. And what Tate was thinking to himself, well, I still can't get to 15 from 6, can I? Not really. I mean, you can multiply by 2.5, I think, but that's not fun. So he said, I'm going to go down to 3. So he divided his 6 crackers by 3. He divided the 6 crackers by 2 to get to 3 crackers, yes, no?
Yeah.
And he divided his 40 crackers by 2 to get to 20 milligrams of sodium to get to 20 milligrams. Yes, no?
Yeah.
And then Tate, like a light bulb went off, ding, ding, all these alarms went off in his head. He's like, hey, I can get from 3 to 15 by simply multiplying by 5. And if he multiplied his 3 crackers by 5, he multiplied his sodium by 5 as well. And these arrows, again, represent what? Bubbles. So these numbers that he used were nice, friendly numbers. We have these nice, friendly numbers. 36 to 6 to 3, and then back to 15, right? And he used a combination of multiplication and division. Sedona and Isabella said, well, that's great and all, but what we did, this was their crackers. I did this quickly. This was their sodium. Okay, so that would be like an extension of their box, right? They said we started with 36 crackers and 240 milligrams of sodium, and we want to figure out how to get to 15 crackers, right? So they really just had a blank right here. And so what they did is they used their calculator and they said 15 divided by 36 equals, ooh, yuck, 0.416666. So then they thought, okay, well, you must have to divide 36 by 0.4166 to get to 15, right? And so what they did is they took 36 and they divided by 0.416666, and they got, ooh, they didn't get 15, they got 86 point something, right? They're like, oh wait, I bet you I did it backwards, right? It's not 15 divided by 36, it is 36 divided by 15, which gave them 2.4, but then they checked it, right? They said, okay, well, what is 36 divided by 2.4? Oh, it worked, right? It's 15. So they did that for the crackers, and then they also did that for the sodium. Does that make sense?
Yeah.
Any questions?